One of the scientific truths that the new James Webb Space Telescope is bringing to the fore is the massive size of the universe. The space-based telescope has just detected a gigantic object lurking in the universe. What huge object has the JWST discovered? How large is it? What are the implications of the size? Join us to explore this wonder of the universe and more as we dive into how the JWST just detected a massive object that is 100 times larger than the Milky Way galaxy. Astronomy is one of the vastest fields in history. Generations after generation, humans continue to be amazed by what we see in deep space. With the introduction of instruments like the powerful James Webb Space Telescope, there is no doubt that we will see more amazing discoveries in space, meaning the hefty development costs of the telescope at $10 billion and the complexities of the design are fully justified. One of the things that amaze scientists and the general populace alike is the dimension of objects in space. Space is massive and has room for a vast amount of things, and it seems nature is determined to fill up that space. Take, for example, one of the largest objects ever discovered, the Alcyoneus galaxy. What is even more interesting is that it was discovered by accident, but that has been true of many life-changing discoveries or inventions. Alcyoneus is a radio galaxy. If you wonder what that means, radio galaxy means the galaxy has a supermassive black hole at its center. As matter falls into the black hole, it produces and releases energy in the form of two radio jets from opposite sides of the galaxy's center, also known as an active galactic nucleus. Radio galaxies have an overall projected linear length exceeding at least 2.3 million light-years. They are rare objects grown in low-density environments. Astronomers study radio galaxies to find clues on the formation and evolution of radio sources. The name Alcyoneus was derived from Greek mythology. The researchers chose the name of the son of Uranos, the primordial god of the sky. Alcyoneus was a giant who fought against Heracles and other gods for control of the universe. You can find a sculpture of Alcyoneus at the popular Pergamon altar in Berlin. Alcyoneus is the largest galaxy ever discovered, and the credit for the finding goes to a team led by PhD student Martin Joe. Another remarkable thing about this discovery is that it disproves some long-held hypotheses about the growth of radio galaxies. How is that? Well, the newly discovered galaxy was captured with two plasma plumes, which is extraordinary. This is because scientists had never spotted these massive things made by a single galaxy. Scientists realize that some galaxies have a sphere of influence that reaches far from their natural environments. How big is the Alcyoneus galaxy? Bear in mind how measurements of objects in space like this galaxy work. Scientists can only take astronomical pictures from a single perspective or viewpoint, which is from the Earth. This means they can only measure the length. For a galaxy, scientists often measure a low estimate of the total length. In the case of Alcyoneus, the low estimate is still crazy impressive. The galaxy is more than 16 million light-years long. That is the equivalent of lining up 100 of our own Milky Way galaxy. Scientists have found about 1,000 radio galaxies, but only 10 of them are longer than 10 million light-years. Alcyoneus was discovered through the analysis of the second data produced by the LOFAR 2-meter sky survey, or LOT. The team reprocessed the LOT DR2 by subtracting angularly compact sources and imaging at 60 and 90 resolutions. The resulting images allow them to explore a new sensitivity regime for radio galaxy lobes and thus represent promising data to search for unknown radio galaxies of large angular length. And as distances in space go, Alcyoneus is close to the Earth. It is located only about 3 billion light-years away, which is still like the backyard of our own galaxy. Astronomers estimate the humongous galaxy spans an area in the Earth's sky that is equivalent to the area covered by the Moon. Scientists were excited about Alcyoneus' discovery because its plumes reveal information about some of the hardest to find filaments of the cosmic web. The cosmic web here means the contemporary, grown-up universe. It actually appears like a network of threads and nodes that are called filaments and clusters, respectively. It is not difficult to see the galaxies and filaments and clusters. What is hard is spotting the medium between galaxies, and this has only been achieved a few times. Scientists hope that Alcyoneus changes this. This is how it works out. Since Alcyoneus inhabits a filament, its plumes feel a headwind while moving through the medium. This obtains with the Milky Way too. But what is of note is that this subtly changes the direction and shape of the plumes. The plumes perform what appears like a slow dance sans partners. For many years, scientists thought that the shapes of and pressure in the plumes of radio galaxies could be influenced by filament properties. But until the discovery of Alcyoneus, researchers had never been able to find an example of such a connection. What they now find is that Alcyoneus' plumes are so big and rarefied that the surrounding medium can relatively easily mold them. So how did Alcyoneus get so huge? There are some theories. The team that discovered Alcyoneus thought it was formed by a massive black hole, a massive amount of stars with lots of stardust, or extraordinary powerful jet streams. However, they discovered that Alcyoneus does not stand out in the three aspects mentioned here. The truth is, the origin of Alcyoneus remains a mystery for now. Many people know that planets do have moons. The Earth, for example, has one moon which anybody with knowledge of high school geography can attest to. Other planets like Jupiter and Neptune have multiple moons. What is not so common, though, are asteroids with moons. Out of over 1.1 million asteroids discovered so far, only about 150 have moon companions. But scientists have discovered an even rarer asteroid, one with 3 moons. How did this asteroid named Electra end up with not 1, not 2, but 3 moons? Interestingly, Electra as an asteroid was not recently discovered. It was spotted for the first time in the 19th century. However, its status as the Grand Commander of an army of 3 moons was confirmed only recently. The 160 miles long asteroid was found in the asteroid belt between Mars and Jupiter in 1873. Its first moon was centuries later, in 2003. The second moon was found in 2014. 130 Electra, or Electra for short, also showed scientists how to find other faint, hard-to-find moons. It is hard to spot the moon attached to asteroids. Asteroids are relatively small and only dimly lit at the best of times, so anything even smaller placed beside an asteroid is going to be dimmer and fainter. It will most likely be vastly outshone by its parent asteroid. This means moons smaller or closer to their parent will be difficult to see. It is for similar reasons that exoplanets are very difficult to find while they orbit their anchor stars. The first moon is just 6 kilometers in length and orbits Electra at an average distance of around 1,300 kilometers. The second moon is even smaller at only 2 kilometers across and has an average orbital distance of 500 kilometers. The latest moon is the smallest of the bunch, measuring only 1.6 kilometers in length. It has an orbital distance of just 340 kilometers, further making it difficult to be observed. It is about 15,000 times fainter than the asteroid. The third moon attached to Electra was discovered by Anthony Burdu of the National Astronomical Research Institute of Thailand and his colleagues. The group of scientists had to trawl through archival data from the Sphere instrument attached to the European Southern Observatory's Very Large Telescope. They painstakingly ran the data through a newly developed data reduction pipeline to remove noise from the raw data with high efficiency. Sphere takes really detailed pictures of objects in space. With the help of a 10-meter telescope, it can tease out images of very faint objects. Interestingly, the third moon was discovered in older images using new processing techniques. They use data processing algorithms to help model the extended glow around the asteroid, called a halo, and remove it. Electra's third moon emerged after the data had been through the processes, so basically the moon was in the data the whole time, but it was invisible to the processing techniques available in 2005. There are still lots of things that scientists are trying to figure out about Electra and its moons. For instance, they don't know how the 4 objects came to be associated. One idea is how another asteroid named Cleopatra with 2 moons formed. Scientists were able to determine that the twin moons probably formed from dust ejected by the main body, but of course the scientists have not determined how common the process was in the solar system. Or the moons may have formed similarly to how the Earth's moon was formed. This means likely from the impact of another asteroid slamming into Electra. Probably it took multiple impacts for all 3 moons to form. One reason scientists try to find moons around asteroids is to improve the accuracy of the calculation of their mass. If an asteroid is without a moon, the mass just has to be estimated using its size and composition, but the method could produce a result that is way off. However, when moons come into the picture, scientists can calculate an asteroid's mass using a set of equations derived by Johannes Kepler. From the mass and size, scientists can further determine the density, which gives lots of clues on the asteroid's composition. It can tell if the asteroid is composed of metals or are just low-density rocks held by gravity. So simply by obtaining the details of an asteroid's moons, it is possible to gain much knowledge about the asteroid itself. The discovery of Electra's third moon is also a test of some sort for a process that can change the way we discover celestial objects. Remember that the moon was discovered by looking at existing data in a new way. This means a lot of moons could remain buried in old data, and all that is needed to liberate them is to look at the data again. Who knows how many moons other asteroids have that are waiting to be found? Let's hear what you think of these amazing discoveries being made in space in the comments section below.